All right, so I have two problems here, 45 and 46. Find the absolute max and absolute min values for a given interval. Guys, this is extreme value theorem. Anytime you're given an interval, you must check the endpoints. So you're going to check 0 and 3. But if you're going to do max and mins, we're going to take the derivative. So on 45, first thing I do is I take the derivative. F prime of x equals 6x minus 12. I find that f prime equals 0 at x equals 2. So that is a critical point. 2 is inside the interval. So I don't have to do the first and second derivative rule this time. I could, but I don't have to. I just have to know max and mins. So I literally just find f of 0, f of 2, and f of 3. 2 is the critical point, 0 and 3 are the endpoints. And I'm using the original function to get the values. So I get f of 0 is 5. I get f of 2 is 12 minus 24 is negative 12. It's negative 7. F of 3 is 27 minus 36, which is negative 9, so negative 4. Everybody, this is my absolute max of value 5 at x equals 0. This is my absolute min of value negative 7 at x equals 2. And that's the answer, all right, for number 45. Now, I am going to spend 1 second here and pull out the graph on the calculator. It's a parabola, obviously. It's a little tough to see, so I'll trace it in red here. Guys, obviously you can see at 0, it's the max right there. And then at 2, there's negative 7. And when it cuts off at 3, it cuts off right there. I erase it there. So we only have this portion of the function. So obviously the absolute max is on the left. The absolute min is at 2. All right? So that's the answer to problem number 45. All right, so we're going to work the next problem, 46. I'm going to just, I suppose I can just delete all this. Let's just delete it. Move my curve off. I don't need that one anymore. I do have the graph of 46 here in a second. So first thing again, without even much thought, I do this. I find that f prime equals 0 at x equals plus or minus 1, but I only take the plus 1. So the only critical point this time is 1 because I am bound by my interval. So again, I have 3 points to check. I have to check f of 0, the endpoint, f of positive 1, the one critical point that's in the interval, and f of 3. F of 0 is 1, f of 1 is negative 1, f of 3 is huge. 27 minus 9, 18 is a 19. So again, I'm not going to write it out this time. It is an absolute maximum of 19 at x equals 3. It is an absolute minimum of negative 1 at 1. If I pull out my calculator graph that I made of the function, and again, this is kind of dark. I apologize. I'll trace it in a second here. The axis, I'll put the axis in green. The axis, oh, that doesn't help, does it? I'll put the axis in red. And then the curve looks like this. So there's our there is a point just to start. Here's our min, and obviously 3 is our max. Global min, global max. Now, if you have a curve and you bound it by the interval, I'll end with this, just one discussion of this whole idea from section 4.1. If I say it starts at A and goes to B, and I have an endpoint, I will say this. It has an absolute max at A. It has an absolute min at B. But it also has this time, this one has what? 2 local maxes at C1, C3, and 2 local mins at C and C2. Alright, so that happens too. Again, max and mins, big thing, guys. Anytime you have endpoints, they must be checked. and critical points must be in the interval.